Okay, we start our lesson. Today is practical lesson number 3. The name of the lesson, determination of the rigidity of a lath. The purpose of the work is to study and master methods for determining the rigidity of metal cutting machines, to determine the rigidity of a 1M61 screw cutting lathe under cutting conditions and under static load. What equipment, instruments, and accessories we need? We need screw cutting lathe 1M61, center mandrel for testing the machine for rigidity. Third, rotating workpiece ring. Fourth, rear center. Through-hole cutter with T15K10 insert. Indicator head. A set of weights. So now write down to your notes the purpose of the work, the name of the work, and equipment, instruments, and accessories. All this you should write down to your notes. Okay, we are continue. Content of work and order execution. The production method for determining the rigidity of the machine is based on the principle of processing workpieces with an uneven allowance variable depth of cut. An uneven allowance during processing is obtained in laboratory work due to eccentricity of the workpiece. When processing an eccentric workpiece to depth of cut, per revolution of the workpiece changes from T suffix maximum to T suffix minimum, which causes a corresponding change in the cutting force and accordingly the elastic movements of the technological system. The magnitude of the elastic displacements of the system, it's like Y suffix S system. When processing a part on a less depths on the displacement of the nodes Y suffix M of the machine, the cutting tool Y suffix T tool and the workpiece Y suffix W workpiece. And we use the formula 1.1. J suffix Y suffix S is equal. It's equal the sum of Y suffix M, Y suffix T, and Y suffix W, where in this formula Y suffix S the magnitude of the elastic displacement of the system, Y suffix M displacements of the nodes of the machine, displacements Y suffix T displacements of the nodes of the cutting tool, and Y suffix W displacements of the nodes of the workpiece. So, what you need to do in this laboratory work or practical lesson? You should write down to your notes the formulas from 1.1 to 1.11. to 1.10. Please write down to your notes all these formulas with components of these formulas. For example, where this part of the lecture. So you need formula 1.1, you need formula 1.2, the rigidity of the system, this formula 1.3, 1.4, the force you calculate P suffix Z, P suffix Y, and Y you should calculate by the formula 1.4, 1.5, and 1.6. So please write down to your notes all these formulas. And all items of these formulas. I give you a time about 20 or 30 minutes. Write down it. Okay, Zaid, let's continue. You should use this value of the parameters, okay, and you should calculate the rigidity of the lath. We should use two methods. First method is production method, and second method, the static load method. First method, the production method. Use the parameters of delta suffix W and delta suffix P to calculate first clarification, E, and then rigidity. What formulas we should use? Clarification. You should use formula E is equal the ratio delta W and delta P. E is equal these parameters, this ratio. You should divide delta W by delta P and you will take E.
Okay.
Then you should write down to the table 1.1. It's we have 3 rings on our mapping. First ring, the medium ring, and the third ring. Just a minute, I repeat for Sumia 2. One more time. You need to calculate the rigidity and calculate it by 2 methods. First method, it's production method. The second method is the static load method. For this calculation, we should use these parameters. Workpiece runout delta W. For the first ring, it's equal 4.2. For the second ring, for the middle ring, it's equal 4.8. And for the third ring, the ring at the tailstock of the machine is equal 4.5. Delta suffix P, it's run out after processing. Delta suffix W, it's workpiece run out. And after processing, after cutting, we have delta suffix P. For the ring, for the first ring at the headstock of the machine, it's equal 0.05 millimeters. For the middle ring, it's equal 0.065 millimeters. And for the third ring at the tailstock of the machine is equal 0.03 millimeters. Then we calculate the clarification E. It's equal delta W divided by delta P. E is equal delta W divided by delta P. After that, when you calculate E, you can calculate the rigidity of the machine. J suffix M, J machine. You need K, Y, C suffix P, and S. You should use Ky is equal 0.9. C suffix P is equal 243. And S. S is equal 0.2. And you can calculate E and J suffix M.
Teacher, where can we find the values of the other? S is 0.2.
Oh, 0.2, yes. S is equal 0.2 millimeters per revolution, per one revolution. 0.2. Okay, it's the same value for each ring. For the first ring, for the second, and for the third ring is equal 0.2, the same value. Ivan, please use this value in the table 1.1 and calculate the clarification E for the first string, for the second ring, and for the third ring. Use the formula E is equal delta W divided by delta P. When you calculate the E, you should calculate J suffix M. Use these parameters of K, Y, and CP and S. S is equal 0.2 millimeters per revolution. So you should use the formula 1.10 and you should use the values from this table. While you calculating, we can look some video about production method of finding rigidity of the machine.
Teacher, excuse me.
Yes,
CP is 243. Yes.
CP 243. Yes.
Okay. And this one, QU is
And
this
0.9 for all rings, and CP
Ah.
is equal of 243 for all rings, for first and second and third rings.
Okay. Thank you.
The different only E between these three rings. So the video about this method. It's a lens. We load the part with three rings. It's workpiece with three rings. First ring, second ring, and third ring. Then we start the cutting. we use the tool, cutting tool. The workpiece start rotating. And cutting in processing. Cutting in progress. It was the third ring. It's medium ring or second ring, and it's a first ring. Then we should measure this diameter of these rings. Another video. Working principle of the lathe.
Working principle of lathe. In this video, we will discuss the working principle of lathe with the help of basic lathe operation. Now, we see 3D model of lathe. Let us see the principal components of the lathe. Workpiece, chuck, tool post, cutting tool. In a lathe, the workpiece is held in a chuck or between centers and rotated about its axis at a uniform speed. The cutting tool held in tool post is fed into the workpiece to the required depth and in the desired direction. The workpiece is rotated and the cutting tool is moved relative to the workpiece. That is why the lathe is also called as turning machines.
A lathe is a machine that rotates the workpiece about an axis to perform different operations, such as turning, facing, taper turning, knurling, grooving, thread cutting, and reaming, etc. To perform different lathe machine operations on a lathe, the workpiece may be supported and driven by any one of these methods. Number 1. Workpiece held between centers and tool driven by carriers and catch plates. 2. Workpiece held on a mandrel, which is supported between centers and driven by carriers and catch plates. 3. Workpiece is held and driven by chuck, with the other end supported on the tailstock center. And 4. Workpiece is held and driven by a chuck, or a faceplate, or an angle plate. The methods of holding the work may be classified under 2 headings. 1. Workpiece held between centers. And 2. Workpiece held by a chuck or any other fixtures. So today, in this video, we'll take a look at the different operations that are performed in a lathe machine. Do you know there are various types of lathe machines available that has their own working principle and mechanism? Click the video link here and find out what are the different types of lathe machines that are available in the workshops. Now let's take a look on the turning operation, which is done by holding workpiece between centers. Turning is the most common type of operation of removing the excess material from the workpiece to produce a cylindrical surface to the desired length. The job is held between the center, or a chuck, and rotates at a required speed. The tool moves in a longitudinal direction to give the feed towards the headstock with proper depth of cut. The surface finish produced by this operation is very good. There are different turning operations can be done. They are straight turning. In this operation, the workpiece is held on the chuck and it is made to rotate about the axis, and the tool is fed parallel to the lathe axis. The straight turning produces a cylindrical surface by removing excess metal from the workpiece. Rough turning. It is the process of removal of excess material from the workpiece in minimum time by applying high rate feed and heavy depth of cut. Shoulder turning. When a workpiece has different diameters and is to be turned, the surface forming steps from one diameter to the other is called the shoulder, and machining this part of the workpiece is called shoulder turning. Eccentric turning. When a cylindrical surface with two separate axes of rotation, with the first axis is offset to the other axis, then such a workpiece is machined by the operation called eccentric turning. Here 3 sets of center holes are drilled. By holding the workpiece at these 3 centers, the machining operation for each of the surface can be completed. Taper turning. A taper is the uniform increase or decrease in the diameter of the workpiece and measured along with its length. Taper turning means to produce a conical shape by a gradual reduction in diameter from a cylindrical workpiece. There are various methods used in taper turning. They are form tool method. In this method, the taper length obtained is equal to the width of the form tool. To obtain the required size of the taper, the form tool is fed slowly straight into the workpiece by operating the cross slide perpendicular to the lathe axis. Combined feeds method. The combined feed is made with the movement of a tool in longitudinal and lateral directions simultaneously while moving the workpiece. Compound rest swivel method. Here the workpiece rotates and the cutting tool is fed at an angle by swiveled compound rest. The base of the compound rest is graduated in degrees. Once the compound rest is set to a particular angle, then the tool is moved by compound rest and wheel. Taper turning attachment method. This method is similar to the compound rest method. Here the job or workpiece rotates and the tool is fed at the taper angle. Tailstock setover method. Here the workpiece on the job is tilted at the required taper angle. The tool is fed parallel to the axis. This method is useful for small tapers. Facing operation. It is an operation of reducing the length of the workpiece by feeding the perpendicular to the lathe axis and reducing a flat surface on the end of the workpiece. Regular turning tool or facing tool may be used for facing operation. The cutting edge of the tool should set to the same height as the center of the workpiece. Facing consists of 2 operations. They are roughing and finishing. Chamfering operation. It is the operation of getting a beveled surface at the edge of a cylindrical workpiece. It is done in case of bolt ends and shaft ends. This operation helps to avoid damage to the sharp edges and protect without getting hurt during other operations. Chamfering on bolt helps to screw the nut easily. Knurling operation. It is an operation of obtaining a diamond shape on the workpiece for the gripping purpose. This is done to provide a better gripping surface when operated by hands. It is done using a knurling tool. The tool consists of a set of hardened steel roller, and it is held rigidly on the tool post. Knurling is done at the lowest speed available on a lathe. It is done on the handles and also in case of ends of gauges. Thread cutting. It is the important operation in the lathe to obtain the continuous helical grooves or threads. When the threads or helical grooves are formed on the outer surface of the workpiece is called external thread cutting. When they are formed on the inner surface of the workpiece is called internal thread cutting. The workpiece is rotating between these two centers. Here the tool is moved longitudinally to obtain the required type of the thread. Here the motion of the carriage is provided by the lead screw. A pair of change gears drives the lead screw, and by rotating the handle the depth of cut can be controlled. Grooving operation. It is the process of reducing the diameter of a workpiece over a very narrow surface. It is done by a groove tool. A grooving tool is similar to the parting off tool. It is often done at the end of a thread or adjacent to a shoulder to leave a small margin. Now let's take a look on the drilling operation. Drilling is the operation of producing a cylindrical hole in a workpiece. It is done by a rotating tool, the rotating side of the cutter known as a drilling drill. In this operation, the workpiece is revolving in a chuck or a faceplate, and the drill is held in the tailstock, drill holder, or drill chuck. The feeding is affected by the movement of the tailstock spindle. This method is adopted for the drilling of regular shaped workpiece. Reaming operation. Reaming is the operation of finishing and sizing a hole, which has been already drilled or bored. The reamer tool is used, which has multi-plate cutting edges. The reamer is held on the tailstock spindle, either directly or through a drill chuck, and is held stationary while the work is revolved at a very slow speed. Boring operation. Boring is the operation of enlarging the hole, which is already drilled, punched, or forged, and it cannot produce a hole. In this, the workpiece is revolved in a chuck, or a faceplate and the tools which are fitted to the tool post, and fed into the work. It consists of a boring bar having a single point cutting tool that enlarges the hole. It also corrects out of the roundness of the hole. This method adopted for boring small-sized works only. Counterboring operation. Counterboring is the operation of enlarging the end of the hole through a certain distance. It is similar to shoulder work in external turning. The operation is similar to boring, and plain boring tools or a counterbore may be used. The speed is slightly less than drilling. Tapping operation. Tapping is the operation of cutting internal threads of small diameter using a multi-point cutting tool called the tap. In a lathe, the work is mounted on a chuck or on a faceplate and revolved at a very slow speed. A tap of the required size held on a special fixture is mounted on the tailstock spindle. Now let's take a look at the milling operation, which is done by using special attachments on the lathe. Milling is the operation of removing metal by feeding the work against a rotating cutter, having multiple cutting edges. For cutting keyways or grooves, the work is supported on the cross slide by a special attachment and fed against a rotating milling cutter, held by a chuck. The depth of cut is given by vertical adjustment of the work provided by the attachment. Grinding operation. Grinding is the operation of removing the metal in the form of mini chips. by feeding the work against a rotating abrasive wheel, known as the grinding wheel. Both internal and external surface of a workpiece may be ground by using a special attachment mounted on the cross slide. For the grinding external surface, the work may be revolved between centers or on a chuck. The feeding is done by the carriage, and the depth of cut is provided by the cross slide. Grinding is performed in a lathe for finishing a job, sharpening a cutter, or sizing a workpiece after it has been hardened. That's it. Thanks for watching. If you like this,
Okay, if you calculate in first table rigidity, you should calculate rigidity in second table. You should use the formula that rigidity is equal delta P divided by delta Y. The formula number 1.11. Delta P is equal the 1750 minus 750. It's equal delta P. And delta Y will be equal 0.26 minus 0.12. And you can calculate the rigidity by the formula 1.11 for all three rings. And it's the static load method to calculate the rigidity of the lens. Please use this method too. The first calculate, it's for ring at the headstock of the machine. The second calculate, it's for ring in the middle of the machine, in the middle of mandate. And the third calculate is a ring at the tailstock of the machine. And when you finish to calculate the rigidity by the static load method, you should answer the test questions.
So, teacher, Py equals P2 minus P1. Same with the Y.
P2 minus P1, yes,
Okay.
and Y2 minus Y1 is delta Y.
Okay.
Tell me, please, are you finished the calculating?
Yes, teacher.
If you finish the calculating, please bool the graph. Bool graph for the static loading method. Like in this figure, like in figure 6. But you only have 2 points, 1 point and second point, and 1 line for first ring, second line for second ring, and third line for third ring. It's load in Newton, and it's Y, delta Y in millimeters. Use, please, this parameter for the first ring. First point load and Y in millimeters, second point of first line load and indicator reading at load. You use 2 points to build a line, the line, for the first ring. When you build first line, then you build second line and the third line. In one graph, you will have 3 lines. If you finished, you should make a photo and send your answers in Telegram.
Okay.
So you should have a name of practical work, enter the measuring results in table 1.1 and table 1.2, calculate the rigidity and build the graph. Zaid, will you send me your answer? And your answer is very well. I give you 19 points for your work
Thank you.
in
Thank you.
practical lesson number 3. So our time, we have the time, 15 minutes. But our lesson is finished.
Okay.